Hello everyone, welcome back to Skill Talk Thermography Expert Series. So till now we have covered a lot in this series. We have discussed different topics that's related to the thermography. So the topics such as heat transfer, EM spectrum, emissivity we have learned how reflecting and how the reflection works here, and also we have learned about how the energy transmit from one form to another form, right? And in the end we have also learned in last two videos that how to set up the camera. So now it's time to bring it all together with one practical on-site example. So this video will be a concluding video. So before watching this video, please make sure to have a more detail. You should go through the last 7 videos that we have created on this thermography, so that you should know that why we are doing these kind of settings. So what is the convection, what is the conductivity and all this stuff, right? So okay, so now we will be consider here one scenario. That imagine that we will be inspecting a plant where there is a large motors and pump systems are there. So let's consider any one of the motor and pump system you want to inspect, and you will be reported from the plant maintenance that okay, there is a issue of overheating of the system of this motor and pump system. So now what will be your goal? Our goal will be is to scan the entire equipment, and we have to capture the reliable IR images, and we have to advise the maintenance team by using all our experience or expertise in this thermography, and we will try to find out the actual root cause that why this overheating problem is there in the system. So first of all, what we'll do, we'll be prepare ourselves. So how we are going to prepare? First of all, please make sure that all the safety rules to be followed, all the safety PPE should be available with you. And the second, what we'll do, we'll be planning the inspection routes. Then let's say what are the components that you want to inspect here. So of course there will be motor, there will be coupling, there will be pumps, and of course these pumps and motors are having their bearings, and also cables will be the part of it, and also the panel inspection will be there. So and the important thing also that we should take care of the ambient conditions, because you can go through the last videos that why it is important to take care for these ambient conditions. So it's very important that we should take care what is the wind, and and how is the rain, dusty, what type of environment it is, whether it's a daytime, night time. So because everything will reflect to your image, right? So everything will have their own effect on the image that we are going to capture in your camera, right? So in the end, what we will do by having all these conditions in the mind, we will be setting our cameras by using the correct IR band. Okay, so so also there is an important thing that you should be aware that okay, what type of equipment you are monitoring. So let's say here we are monitoring a pump and motor, so I should have an idea that how the conduction process can take place in this equipment or the part that you are scanning. Okay, and what is the conduction? It's in very detail we have already explained this phenomena. One is the conduction, one is the convention. So in the short, if I will tell you that conduction will give you that how the internal fault it's transmitting the heat to the surface. Okay, and what is the convention? So convention is this, that maybe that the target will get cooled by the let's say by the air, or wind is there, or any cooling fan is there nearby, right? Because in the end we know that our camera only detects the radiation, and all these phenomena, that is the conduction and the convention, that they will affect the radiation amount of radiation energy that is coming out from the monitoring asset, or you can say in this case the pump and motor. So okay, so now finally what we'll do while setting the camera, we will be adjusting the most important thing, that is the emissivity and reflection, because these are the two important parameters. If we didn't set them correctly, so 100% we are going to get a very false readings. So definitely we have to have a look around the equipment, because in the most of the cases you may found the pump is with the shiny stainless steel surface, right? Especially the casing. So make sure that you should know the proper emissivity of that case. And since we have already discussed in the last video that how you can adjust the emissivity, and you can check that what emissivity value is suitable for that particular asset, but still we will be repeating it here again. So let's say you want to measure what emissivity will be the best to monitor the pump casing, which is having the shiny stainless steel surface. So first of all, what we will do, we will be applying a small black electrical tape, And please make sure that in the reference images you will may find the the tapes are implemented on the, or you can say the tape are put on the electrical panel. So please make sure that you should not do this thing in the live panel. Of course it should be the equipment should be shut off in this case. So please make sure that all the safety protocols that you should follow while putting this reflecting tape. Okay, so first step will be that we have to apply the electrical tape to the safe area, let's say on the pump casing, and we will be setting the emissivity in our camera, that is 0.95. that is the emissivity of a black tape. So now we will measure the tape that, or you can say the tape spot, so that we can we have to adjust the emissivity or reduce the emissivity. Till then we will not get the same amount of temperature that we are getting on the reflecting tape. So this is how you are going to set the emissivity of that particular pump casing. And please make sure that you should always take care of the reflected apparent temperature, that you can measure by using the foil. And if you want to have the more detail on this, please refer to our last 7 to 8 videos that we made on this thermography. Okay, so now let's say that we will be start scanning the region. So now let's say you have started from the motor. So in the motor, first you will scan the entire motor. We will be starting from the non-drive-in of the motor, then you will be inspecting the casing, and then you will be inspecting the drive-in bearing, and then you will be taking care you will be inspecting the housing, or you can say the coupling, right? Of course, please make sure that if any coupling guard is there, so please make sure that you have to safely remove this before performing this thermography, by chance if you don't have any access to the coupling. So it will be easy, and the results will be more accurate. And then you will be coming towards the pump. You will be inspecting the pump casing, pump bearings, and maybe the suction or discharge line if needed, so that you are going to decide on the site that which part you need to inspect, right? So this is how you will be scanning the entire region, or you can say the entire equipment. Now once you have scanned all the area properly, now what you will do, we will be start the reporting part. So once the data has been collected from the site and it has been saved in the images, please make sure the emissivity and the reference temperature should be reflected, temperature should be perfect. So once everything get saved, then these images can be dropped down to the software, and from there you can have do your analysis, right? So also please make sure that all the important points in the or you can say let's say the bearing points, or the winding temperature, or the pump casing, so all these important points you should highlight from the spots, or you can say the different type of markers are available in the camera, and also you can put this later on once the image is saved in the software. So you please make sure that all the hot spots and the reflective tape reference and all these spots to be temperature to be mentioned in the report, right? And then to have more accurate analysis, if you have the let's say that you are having the last historical data, then you can compare with that, or otherwise you can just compare the data of this pump to the similar application that another pump is having, let's say. So you can compare with that, or if you don't have anything, then you can use the basic standards for your inspection, right? So then you will be, once the inspection has been done, then definitely you have to mention the faults, that what fault, or what are the abnormalities that you have find out during your inspection. So you should prioritize the faults basically in 3 sections. One is for the critical one. Once you highlight any fault as a critical, that means the immediate action they have to take. Another one you can put as a moderate, or you can say the alarming stage. So in this they have a certain time period that okay, they can schedule the maintenance. And in the last one you can just put the normal, because the third one is the normal, that let's say that you didn't find any abnormality in the equipment, so that will be considered as a normal, right? So also if you need, you can just use as a color coding also. Let's say that you are using for normal you are using green, and for critical you are using red, and for the moderate condition you are using yellow. So it will be very easy for the maintenance team to have a differentiate, right? So I believe we have covered all the part here now in this series. First we have in our last 7 to 8 videos we have shown that how these concepts basically will play an important role in the thermography. Let's say what is convection, what is conduction, and how the IR image transfer from the object. So all this stuff that we have discussed in our last videos, and this video we have covered one practical example, that how you will be using all this stuff that we have learned, all the phenomena that we have learned. So how you will be using it if, let's say, we have considered here one machine and let's say we are going for the inspection. So this video covers all those points in one single shot, right? So now we are having the full understanding that how heat is transferring, okay, what are the internal patterns for that, and what is the role of EM spectrum, you know, that so that you can choose the right camera band for that, and also what is the role of emissivity, reflectivity. And in the end also we get to know that what is the systematic approach, that how you have to generate one entire report for the critical asset. So here I think we have entirely covered one basic how to perform a thermography. So once you have an idea or you go through with all these 8 videos, so definitely I can make sure that you can easily do the thermography of the equipments. I know that still more things are there to cover up, but this is just for the basic and the beginners. So very easily if you go through with the, with all these tricks and the phenomena that we have explained you guys in this videos, in this series, so definitely you can perform the thermography very easily, right? So of course I know that there are lots of other things to cover, but that we can cover later on in the let's say the advanced section, or you guys can put on the comments in the comment section that okay, what especially topic that you want to cover more on this thermography video, right? So thank you guys for being with us, and thank you for listening to us. We will try to cover all the topics and all the technicalities and all the new methods that relates to the condition monitoring. So let's say thermography we have covered. Now we can go for the vibration, then we can go for ultrasound. So one by one we will be covering all the techniques that are used in the condition monitoring, and we'll make sure that all our YouTube family should have the knowledge for all the CBM techniques, and we'll make sure that everybody will be sound very technical in this. Thank you guys. Let's meet in the next video. Till then, take care. Goodbye.